Hey everyone, it's Andrew Brown, and welcome to the free Gen AI Bootcamp. I'm here with Kierra, and she's going to be helping us with the data side of it. I'm going to be honest with you, I'm really awful at data, and so I need this primer really bad. And Kierra was very generous to break it down for us here. And so I'm going to just before we look at the slides, I'd like Kierra to introduce herself, and then we'll get to it.
Okay, sure. Hi, everybody. I'm Kierra Dotson. I am the founder and CEO of the Data Block, which is a data career coaching and then also consulting company. And I also do Kubernetes and data contracts on the side. But yeah, thanks for inviting me, Andrew.
And thanks for having us here or being here. And I'm going to bring up, whoa, that's not right. That's not right. I'll get it right here. There we go. And now we have data pre-processing for Gen AI, and all that stuff is just me. That's not AI itself. But we'll jump into it here. So data pre-processing for Gen AI. And before we even jump into this, I guess my question is data processing really different for Gen AI, or is it the same thing but slightly applied a bit differently?
So it's generally the same thing across all the different data realms. It just slightly differs depending on the small individual steps. For instance, like fine tuning and things of that nature. A data analyst might not have to do that. They'll just have to pull in and do some data quality checks and things of that nature for their data. So data pre-processing, very important, happens across all levels of data and AI. What your skill set just might vary on what your particular goal is or whatever it is that you do in your role.
Cool. All right. Well, let's jump into it, and let's see how hard this gets.
All right, let's get started. So again, we're talking about data pre-processing for Gen AI, which is very crucial and often overlooked in AI at the moment. While large language models are incredibly powerful, they are not magical and they're not all-knowing software. So I'll keep saying this, repeating this a million times. You're going to probably get tired of it, but it's so important. The quality of the model's output depends heavily on how the data is prepared. If the model is biased, it's not the model, it's the data. If the model gives wrong information, it's not the model, it's the data. Um, mhm.
Oh, sorry. So, does that go along with the popular slogan "garbage in, garbage out"?
Exactly. And that's
Okay.
also going to be featured in the slides as well. But a good example of this is let's say that a customer service company, they're implementing their own chat GPT and they feed it their own customer service transcripts that some of their customer service agents might use. So a lot of times those transcripts are filled with some inconsistencies, like maybe the date format is different. Also, addressing different customers might be different. There might be a Mr. or Mrs. The way those things are spelled. Also, missed languages if some of the representatives are bilingual or even just like talking to different customers in different regions or countries. So, without proper processing or pre-processing, the AI might generate inconsistent or incorrect responses if that data is not standardized across all those different agents that have that data. Um, that's my primer. So let's get started with the agenda. We're going to talk about why pre-processing matters, just so you get a better understanding of what it does. Some Gen AI misconceptions. We'll also talk about some Gen AI examples that have gone wrong at popular companies. We'll talk about some data quality, my favorite topic. We'll also talk about some best practices, and then I'll leave y'all with some key takeaways to keep in mind as you're continuing to go throughout the boot camp. All right. So, why does pre-processing matter for Gen AI? So, data processing is pre-processing is the process of transforming raw data into a format that can be efficiently and effectively used for model training. The most important part of that is raw data because that's typically where data starts at before it is used by anyone, whether it's an analyst or it's about to be used in the pipeline for data engineers. A lot of times that data is transformed to make sense to the business or whatever customers that will be using it. And again, you want that input data to be as aligned with the requirements for the model you're using to ensure that the outputs or the response of the model makes sense and is valuable for the users. So the better the data is prepared, the less likely you'll have an overfitting model. And by the way, overfitting is just when a model is so fine-tuned to the training data that it performs poorly on new unseen data. So you just want to make sure that the data is as close to great as you can get it, the first few times, because also overfitting means that as you continue to fine tune your model, it gets more and more expensive to do as well. So let's talk about some pros of pre-processing. So one, of course, is your improved model accuracy. So your models are basically responding with an output that's based on patterns and relationships is picked up in the data. A lot of that's what that is, especially like when you look at ChatGPT. As we heard, it scraped all the data in the internet. When you ask it a question, it'll easily go and retrieve some of that data that it might have seen that matches closely to the prompt that you give it. Same thing with all the other Gen AI models, whether it is text or image based or video based as well too. It just finds different ways to make sense of that training data and then give that output to you. But properly processed data will help the model to learn those patterns and relationships faster and easier, so the response will be even cleaner and better for you to understand. There's also better generalization. So clean and standardized data helps in building models that generalize well to new unseen data, improving their robustness and reliability. And then lastly, minimizing bias. So techniques like dealing with the missing values effectively, they ensure that the model training is not biased or skewed or even inappropriate for the prompt that was given.
It's really interesting because I think Rolla was telling us that a lot of the models out there are trained on all of the data on the internet, which
Mhm.
is a bit disconcerting because like if anyone's been on the internet before, it's a wild, wild place. And so I almost kind of wonder what they're doing under the hood to make these things not spit out crazy. But just coming to the word pre-processing, I understand that in a data pipeline, there's a bunch of steps, and I've heard of this pre-processing stuff. Is that like a big category of things? Is it like one really specific thing? Like how big or small is it in our pipeline?
It's a big category of things. Again, it just depends on what the use case is for the data and then how messy the data is and also the data types. So processing, I would say structured data probably is, I would say, more of like the easiest because there's already a consistent format to begin with. Maybe it's as simple as you just having to remove any duplicates from your data that you see, whether it's just some text data or even anything such as we're also removing some fields or something if some missing columns are there or some missing rows are. But of course, then it comes to dealing with images or JSON and anything else that's unstructured. If there are some broken JSON brackets or something like that, that's a lot to have to deal with and parse through, especially it's as engineers, it's already hard to figure out what's going on, like you're missing a comma in your code. So imagine an AI software having to do that and it hasn't been trained on how to do that already. It's flying blind. So that's why pre-processing matters for sure, especially in the context where when you're serving data to people, like say like you're serving it to an analyst or something, they might not understand the technicalities behind how that data is processed, and they might also not understand the context behind that data. They've just received it. So that's why pre-processing matters, because you're trying to make the data as formatted as possible to match the end user's needs.
And so, like if one example, and I want to know if this is pre-processing, but like one example in the boot camp is that I want to take a movie and I have its subtitles. And so it has all these time codes in there and I end up removing them out because I just want the raw language text. Is that pre-processing?
Yep, absolutely. And that actually falls under the data quality category with, yep, standardizing your data, making sure it's formatted, without the time codes.
Cool.
So yeah, next slide. So let's talk about some Gen AI misconceptions. Um, yeah, some myths, and then I'll give you the truth about it. So the first one is one, LLMs can understand any data format. No, it cannot. So let's say, for instance, streaming video is not something that's very popular right now with a lot of LLMs. That's something that's starting to emerge, and I can't even begin to think about what other types of data formats that might come out that we haven't handled yet. A lot of times we're just seeing text and images and maybe any already pre-existing video that is fed into the AI models or LLMs to interpret and spit out information for us. And then also another important thing is that feeding the model properly or properly formatted data significantly improves its pattern matching and response accuracy. A good example of this is JSON, which is basically it's almost like a documented way to send out large amounts of data that could be attributes of something. So let's say you have a messy JSON document and it has missing brackets, there's inconsistent quotation marks around some of the fields. That's going to be hard for the average normal human to understand. So of course, it's also going to be really difficult for a model to understand as well too, because it also has to parse through and sort and understand the information just like humans do. But if you give it a clean, properly formatted JSON document with proper spaces, brackets, and quotations, it will digest that information much easily, and then so they'll speed up the time for the training, and then also cost effective too. You're not using as many resources to parse that data, and then third, it reduces probably the amount of hallucinations or it having to think twice about, oh, was this formatted properly? Oh, was this formatted properly? Oh, well, this document wasn't like this one because the quotations were gone. They get confused just as we do.
I would say that LMs must have a really hard time for me because I'm always spelling everything wrong. And one thing that I think that might be making people believe that LMs can handle anything is because of these AI powered assistants.
Mhm.
Because I'm thinking that they are doing pre-processing. So like if you give it a PDF, it's running a pre-processing step, extracting out the information or doing something to it. Now, again, I'm not sure exactly because we don't really know
Mhm.
the interior there, but sometimes there's magic happening. Like you had mentioned about video, like we know that ChatGPT, whatever the latest version one has video, but like how is it doing video streaming? Because yes, there are technologies out there, but I can't find any open source ones. So if they've solved it, they're not sharing it with everybody else.
Oh
Mhm.
yeah. I definitely agree with that. It would be really cool to see the code behind that, but of course, they wouldn't want the competition to know what's going on. I do hope that as time goes by, more open source LLMs are shown, or just the code behind all of that. And I think it will as the technology advances. It'll become less of a ooh look at this new thing, and it'll just be, oh, this is standard. So of course I'll share with everybody else. Um, but that's
There,
going to take some time.
there is a model called IBM Granite out there that is 100% open source, and they say where all the data comes from, but I couldn't tell you what that looks like. I don't know where to find that. So they said it, and it must be true, but I'm not sure. I'm not even sure where to look to understand it or to replicate it. So yeah, it's got to be made easier, and we need more of these examples.
I 100% agree with that. And I think that's actually a really good thing that they did. Sometimes I also get a little skeptical because I'm like, okay, how can we confirm for sure that it's all of the data that you're really showing us all of the data? You can say that, and you probably have a bunch of data that you could show us, but what's also going on? Especially because IBM, they're government contractor. So if they use AI, then there's probably some type of contracts to have in place to where they can't show some of the things that they're using under the hood. Or maybe they have their own specialized platform that they get to use for IBM Granite or something like that.
Maybe, yeah.
Yeah. So, and then the second myth is pre-processing isn't needed for text data. I have a really cool example here, basically just showing, like, let's say, again, customer support chatbot. It pulls in some information from the database, and that's literally the text string. This random piece, urgent, product arrived broken, ordered on this date in 2023, and here's the order number, disappointed, sad face, sad face, sad face. That's very confusing. For the AI. There's a lot
The
to go on. What
the
if
oh sorry, I'm trying to remember what the opposite of a smile is. The sad faces, they're not they don't provide sentiment analysis.
yeah, it may or may not, depending on if that's what's hooked up. If they have like a library imported for that code. For all it knows, it could just be like, oh, um, this is just a random like quote. What is it called? Oh, it was parentheses, like
Or
just
well, yeah, it just looks like character mistakes,
these
right?
just random characters. How am I supposed to read this in? Is this actually a date here that says ordered on blah 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 blah, or is this just a bunch of numbers and characters thrown together? You really don't know how the code behind the AI model or the AI is parsing any of this stuff. Whereas if you look to the right, it's a little tiny. You'll see a better way that the customer data is formatted, of course, you have your fields, and then you also have whatever the value is on the opposite side. Much more easier for the model to break down and understand and interpret. So the reality is structured, clean text data leads to more reliable and consistent Gen AI outputs. Again, it's not as confused. It's able to make better sense of the data. So it's able to have a higher chance of returning something back to you that makes sense. Or is also isn't hallucinated. Because it might just say, oh, yeah, sure, this person was happy because it doesn't know what to do. But maybe the AI was trained not to tell you that it doesn't know what to do. So it'll just respond with anything because it has to respond. So, yeah. The third myth is we can just dump our documents into RAG. Um, and many people think they can do that and it'll work perfectly, but you need proper pre-processing for that. So let's say you need to remove some irrelevant headers, maybe standardize some of the formatting and structuring the content. Otherwise, the retrieval quality suffers greatly. And by the way, if you don't know what RAG is, which is retrieval augmented generation, it's basically hooking up a database to an LLM so that it can reference the database for any specialized information that the model might need. It's a cost-effective way to feed the model more data without having to fine-tune it, because fine-tuning actually is quite expensive. It's also a really good way to customize your model without with customer-specific information. You might see a lot of companies creating their own internal chat GPTs, and that's so the employees can feed in company data and use it themselves. And it keeps the model up to date as well too. Like for instance, if you have certain policies that you might have, let's say you have HR policies from 2025, but you train the data or train the model on data from 2020. It wouldn't be a good bet to just leave that data from 2020, especially if the HR department needs it, because that could be a compliance issue if things go wrong because of the old information. So, you could put some updated policies or updated information into that vector database, and then that LLM now has relevant information to pull and output to the user. And then once again, the principle of garbage in, garbage out is especially relevant. A good example of this also is Copilot. Its ability to suggest code, it just depends on not on having access to the code repositories. That's great, but the data that it was trained on, it had to be clean, it had to be well documented, and properly formatted code examples to understand how to help people with fixing or structuring their code or commenting or fixing spacing and things of that nature. It didn't just jump out the box as a perfect AI product. The data behind the AI model made Copilot what it is today.
We're having our office hours earlier today, and in the upcoming week we are looking at, well, when this video comes out, it will be that week, but working with AI coding assistants.
Mhm.
And I was saying that with GitHub Copilot that it's referencing all this raw material from their repos, and sometimes you just get really bizarre code, whereas other providers, they're not just dumping it all in a rag. You know what I mean? There's more careful thought in terms of how they work with structured data. Some of them will actually go in and, as opposed to just referencing code, they will reference technical docs about the specification, so that
Yes.
it's more intelligent in terms of it generates out. And so structured data, even in a vector database, which I guess, like when we think of structured data, we think of a relational database, but like vector is a little bit unusual because it really does feel like a dumping grounds for data, and it will just kind of work. But I imagine there has to be some work to be done to reduce the noise, or yeah, as you say, removing noise here before you place it into that vector database, or whichever source you want. Sorry.
That's actually a really good point that you brought up. So, because it reminds me of data lakehouses, which was what a lot of companies use to just dump random data into when they're not sure of what they want to use it for. And a huge issue with those lakehouses is that no one understands what the data is in there, or even how to sort through and filter through all of it, because it basically just became, like, they call it a data swamp, or
So
it's just
sorry, the data lakehouse, that's a retreat for the data team.
exactly. It
Sounds
feels that way, but it's not.
like it.
It feels that way, but not the funnest one, especially
Mm-hmm.
when you actually have to go in and pull and retrieve stuff.
Mm-hmm.
So that's actually a really good point you brought up about the vector databases. There's something called a data catalog, basically where it's basically like a data dictionary for all the data that exists within the data warehouse or a data lake or a database. it'd be really cool to actually see if there are some vector data catalogs that do exist. That way people can make sense or keep track of the data that they have.
Data catalog, that's it. It's a mapping of the schema. So you think I would know because I recorded it for AWS Glue, and you define a schema with something called open tables or something. It's weird. I know all these technical terms, but that doesn't mean I know what's going on. So because I didn't finish the data engineering certification for AWS, so I don't know just yet. But is it supposed to be like a schema mapping to your data? Data catalog just holds a reference of schema.
Yep, references the schema and just also it's in a way for you to just understand and see what's in your database. On a schema level, a high level overview of what's in there. So yeah, just that would be that just for vector databases. And then let's talk about some real world examples where insufficient data preprocessing led to some Gen AI failures. So these weren't just technical glitches; they had real business and social impacts down the line. So, for instance, 2014, Amazon created a AI recruitment tool that was basically supposed to help screen applicants' resumes and rate them. So they had an actually really big issue because it started to discriminate against women.
Mhm.
The root cause of that was the model was trained on a data set, and that data set consisted of resumes submitted by men over a period of 10 years. So the training data wasn't pre-processed to remove any gender indicators or address any historical hiring biases. So if someone had something like, oh, they were on like the women's volleyball team or the women in tech committee or something like that, it flagged it or deemed it as something that was bad just because they hadn't seen that women's keyword pop up across all the years of that training data from the previous resumes. So the system basically learned from past hiring decisions that were themselves biased, and it created a self-reinforcing cycle.
Well,
So
oh, sorry. And so this is from 2014, and this is before LLM. So, and that's really interesting because now it's like imagine people just took 10 years of resumes and dumped it into a rag and said, or did fine tuning, said, go figure this out. It would probably mess up just as bad as this thing, but people are faster to make mistakes. Sorry.
yep, exactly, 100% what you said. The same data over time, if they haven't handled for those biases or tried to look at the data and inspect it more, did some like exploratory analysis, they won't catch things like that. And that's also why I said it's not just about just a technical mishap or something. Now Amazon in that moment, they looked as if they were not really good with just having diversity. It also probably hurt them as far as that's potential lawsuits. So that hurts their brand. So now they have to double down and try to figure out how to rectify the situation. On top of them having to scrape this AI tool that they spent a ton, like at least millions of dollars on to create. Um, so the next one was in 2016. Microsoft had a conversational understanding chatbot named Tay. This one was very interesting. So it was designed to pick up lexicon and syntax that was from interactions on Twitter, basically people posting and responding. It was designed to mimic the language of a teenage girl using slang and all that. And it took a turn because it started posting and responding to people with insanely inappropriate thoughts. So the reason behind this was because there was a person that posted about the bot on 4chan. And if you don't know about 4chan, it's basically a forum for trolls and people who are very mischievous to say the least. And they basically encourage the users to inundate the bot with racist and misogynist and anti-Semitic language. Just a bunch of really, it was just saying, hey, make sure you respond to the bot with the most inflammatory things. That way the bot can pick up on it and train itself on that data, and then and also start posting like what we're telling it to post like. So it did pick up on that language and it mimicked it. So yeah, there was no pre-processing for handling that incoming data, which was the training comments or the Twitter comments. So they would have benefited from filtering and doing some validation checks on that Twitter data or that it was receiving, and then cleaning up that raw social media data. I'm sure they had some checks and filters to begin with, but they probably just didn't predict that that was the turn that was going to take down the road. And that's also why pre-processing involves having to think outside the box and having a diverse team who can think of all the different use cases or edge cases that the AI might experience.
Right. And I know we're talking about data pre-processing. Again, I don't know all of them off the top of my head, but I'm assuming there's a data validation step to validate the output of the stuff. And so it sounds
Mhm.
like both ends need to be covered. But it's weird that these things that went into production and they were never detected. So it's just like, are they missing the other part of the pipeline, or it's like what you don't think of, you don't see.
Exactly.
But
And
also,
that's the
oh,
thing.
sorry.
Yeah, that's the thing. They probably didn't think of that at the time. They were like, "Oh, it's Twitter. It's fine. Everything's gonna be gone." They didn't predict a guy from 4chan basically starting a whole movement to skew the responses of this, which is why it's good to have. That's why I was saying different backgrounds. Maybe people that were well versed with how um, some people might behave on the internet. Everybody doesn't have the best intentions on the internet, especially with Twitter. And
Oh, sorry.
then,
Yep.
yeah, go ahead.
Oh no, I'm just the next one. Meta. I was trying to read the word Galactica AI.
Yes, Galactica AI. They had it in theory it was supposed to be great, but basically it was an AI bot. It could summarize. It was kind of like what Notebook LM is today, but more for science. So it could summarize your academic paper. It was going to solve some math problems. It could generate articles for Wikipedia, write scientific code, and do a bunch of other crazy stuff that more science people know with all the science talk and jargon. But the model hallucinated too much, basically, because it was due to training data that included unverified scientific content, and there was a lack of annotation as well too about where the data was coming from as far as the scientific articles that were shared. And also, there were peer and non peer reviewed articles being used. So, yeah, basically, it had to be taken down within 3 days because it generated some convincing but false scientific papers. And they faced a lot of backlash in the academic community because, of course, the scientists went and did a double check on some of these papers and it went left very quick. So, once again, data quality and verification checks, they missed them.
In my town here, I was running a Seniors for Gen AI, and I was showing
Mhm.
off Notebook LM to take all our bylaw documents for the
Mhm.
town to make people more informed about how they can try to parse it. And so they have a feature that turns it into a podcast. And so I
Mhm.
was doing a podcast on bylaws, which is very boring, but right away it started jumping in and talking about things that sound like conspiracy theories about, like, as if the town CEO was colluding with this stuff. And it was really wild, but it was just like, yeah, these things can make some wild stories.
Yes, it can go to 0 to 100 very quick. Did you hear about, well, I mean, it's so hard to tell time these days, but the lawyers who use ChatGPT and it came out with random court cases that they were trying to use in their hearings. And so a lot of them got in trouble for that. I think one, two might have even lost their license to practice and things like that. So um, oh, and then of course the case where people were finding ways to inject and hack into people's software systems. A lot of engineers they'll use ChatGPT for code snippets and things of that nature. And then sometimes ChatGPT will recommend you import some libraries. Well, someone would actually come up with a fake library that was actually going to be used to inject and steal someone's data if they use it, and boom, that's exactly what happened. Or the case where ChatGPT will say, "Hey, import this random library that exists. It totally exists, and it doesn't exist."
Hmm.
And a lot of engineers that don't know to check or double check the data, they'll try to ship that and they'll be in production and then boom, their software fails because they used ChatGPT or took ChatGPT's word for whatever it outputted. So, yeah. Next, we're going to talk about data quality, which is very important. And you should always run an assessment on the data sets that you're using, regardless of whether it's for AI or if it's just for any data analyst work or really any type of position that you're in, because data is always relevant. But again, high quality data is the backbone of successful AI initiatives. Let's break down some of the data quality components. So, um, Let's say accuracy. So that basically means that the data correctly represents the real world condition. Let's say that you're working on a restaurant menu chatbot. Not sure if that's the greatest use case to have for using AI, but sure. But let's say it has some prices that were based on 2020 because that's where the training data is from, but it's 2025. So if someone's trying to look at the prices on the menu or look for a dish, and they're looking at prices from 2020, and then they go to order, and of course it's 5 years later, and inflation has hit, they're going to be really upset. Their dish is now $15. They were expecting something cheaper. So yes, the output was accurate based on the training data, but it was not accurate based on today's current prices.
Sorry. So this actually is a useful use case because in my town, I'm trying to build like our own social portal, and so I've been getting all the restaurant menus using Perplexity to go grab them,
Oh.
and some of the data is out of date. So no, it's well for me, for me, it's a good use case here.
Yeah, which sounds good. Well, that's great. At least somebody's going to be using it and it makes sense. But yeah, the next one is completeness. Sometimes that involves missing values from a data set. But basically, what that means is all necessary data points are present, especially ones that are relevant to whatever it is that you're trying to solve. So let's say that you have a medical knowledge chatbot in this chat, and it's connected to a RAG or a vector database, and it contains information about a lot of different drugs, the chemicals in it, what it's used for, but it doesn't contain anything about drug interactions, such as how often you need to take it, or maybe any side effects. That is that's bad, because if someone is using that to learn how to or to take something, and it doesn't show any information on how that drug is supposed to be taken, that's a potential lawsuit. So that's what I mean by having completeness, making sure all the data that's relevant and what you need for whatever use case it is present and there. The third one is consistency, which means standardizing your data. So the data does not, and making sure that the data doesn't contradict itself across different data sets. Bringing it back again to the customer service AI bot. Let's say it's for a retail company, and it helps with all the product information. Let's say that in one data set, the product is referenced as a jacket. Maybe this is the inventory data set. But if you look into the marketing team, that they market it as a sweater. So if a person is going on and let's say they're on the site and they're like, okay, what are the coolest jackets? The AI is not sure if it should say, oh, this is a jacket or this is a sweater, because it's technically marked as both, but it doesn't know if it should say that. So it might hallucinate and say, no, there's no jacket here, or it might say it's a jacket sweater or something like that. And that's a very mild example. Imagine if this is something that's bigger, that's in healthcare or something like that, where a doctor really needs to look at a list of prescriptions or something, and something is missed, and they are dealing with a life-threatening condition. So it's very important to think about that as well when you're dealing with data quality. Last one is timeliness, and that's just making sure your data is up to date and relevant. Example, legal compliance AI assistant using training data, and it's based on pre-2023 policy regulations. Again, making sure you might want to connect that to a RAG to continue to get the most up-to-date regulations that's going on. Also, making sure that the data is relevant. If you have an HR assistant and it has information about IT security protocols, that's not really relevant because it's only pertaining to HR. So now that model can get a little confused on HR policies. And then also sometimes IT might have the same acronyms as HR, but they mean completely different things. So if someone's asking about something, it might give something IT related and they don't know it, and then boom, there's another policy or compliance issue. So all of these data quality checks or components are extremely crucial when validating your data sets. Let's get into some data preparation best practices. So these are essential steps of preparing your data for Gen AI applications. Think about this kind of like a recipe. Each step builds on the previous one to create a robust, reliable AI system. So let's start with data cleansing. This is like sorting through your ingredients before cooking. First, you might want to remove some duplicates, just like you wouldn't want to add sugar twice to a brownie recipe. It'll be an extremely sweet. You want to do the same thing. any, relevant or continuous customer information or any type of policy information, whatever it is that you don't want to have duplicates of, you do want to remove it. Also, it'll just save space for when you're putting in your data set. Then you also want to handle any missing data. That's similar to deciding what to do when you're missing an ingredient. You know, um, do you want to, do you want to substitute it out for something else, or do you just want to skip it altogether? Depending on depending on a data point, that's when you determine which step or which technique you should use. You also need to think about removing noise. So you want to think about this as maybe filtering out any seasonings or any ingredients you don't want on the counter as you're making your recipe. So if you're making brownies, you probably don't want garlic powder in your pile of ingredients. That doesn't sound like that would make the best flavor profile. And then lastly is handling your outliers. Those are extreme values that could throw off your entire system. So if you're dealing with something that involves weather data, let's say you get the random data point that says 1,000 degrees Fahrenheit. That in your typical range your typical range is like 25 to 100 degrees. You're probably going to throw that out since that's an anomaly. So let's move on to data preprocessing, that where you transforming your clean data into a format that AI can understand. So you need to encode categorical values. And categorical values are basically any type of text labels or things or attributes that we understand as phrases, but AI understands everything as numerical. So let's say you have hot, warm, and cold as maybe some labels for something. You'll want to convert those into numbers. You also want to scale your numerical data to ensure that all the measurements are comparable. So think about, like, imagine you're converting some recipes from different measurement systems, like, the US customary, I think there's metric, and then there's also the British imperial. And you want to convert all of them into one standard metric measurement. And then we'll also talk about splitting the data into training, validation, and test sets. That's just crucial for understanding or ensuring that the AI can generalize well to new situations. So feature engineering is where the magic happens. That's where you create the new, meaningful features from your existing data. For example, instead of using like raw temperature data somewhere, you might create features like temperature change over 24 hours or deviation from seasonal average. It's all based off of the business outcome you're trying to solve for, and then also what data points exist. But to break it down a little bit more, a feature is basically a variable or attribute that's measurable, or it's like a characteristic of a data point, and it's used as input for a machine learning algorithm. So, example data set for housing prices. It could have some features like the number of bedrooms, the square footage, the location, and the age of the property. That's kind of what features are. Next is data labeling and annotation. It's adding context to the data. So it's like adding cooking instructions to a recipe. You're telling the AI what each piece of data means and how it should be interpreted. Also very useful for when you're looking back at a data set and you're trying to make sense of why you categorized it or labeled it or put it in a certain batch with other data as well too. Lastly is data privacy, and that's crucial as well. You need to ensure that you're protecting the data or sensitive information while still maintaining the utility of the data for AI training. So in the next sessions, we'll be deep diving into each of those steps using a real world example, building an AI Japanese speaking coach. And it's basically going to help people perfect their Japanese pronunciation.
And Kierra, how is your Japanese? Is it good or?
It is in the negatives. In the negatives. The only thing I can say is Watashi Wasta, and that's because I'm an Italian. So, that's, how about yourself?
I know a bit more, but if you consider how much time and money I've spent to learn it, I should be a bit farther along, but that's okay.
You get there someday. It's okay. I'm also learning extremely slowly, by the way, French. So I get it. Duolingo has gotten a lot of my money.
But French or Canadian French?
Oh, French.
Okay, French. Fair enough.
Next is, okay, yep, let's talk about data cleansing in the realm of our Japanese speaking coach. So first we're going to do is remove some duplicates. Let's say that you have multiple recordings of the same phrase by a particular student, and all those files are named exactly the same, where it's audio file from October 12th. There's three ways you can go about this. So you can either filter out all the audio recordings by the most recent audio timestamp. That would be helpful if you aren't trying to save state, and by that I mean you're not trying to see over time how the person's phrase is improving. Maybe you're just your MVP of your app. The second one is you want to create some unique file names, which I will always stand by, especially from a human point of view. It'll help people to understand. So let's say you want to use a student ID and then maybe the phrase and then a timestamp to get a better understanding of how maybe you could sort through a query for a specific audio file. The last one is keeping logs of the recordings for future troubleshooting and analysis, which is very important and hits with my DevOps background. Sometimes things go wrong. In the event that there is something or error you need to look for, you do want to have logs to understand and get a better view of what exactly happened to cause an error in your AI model. And even better, you can use that information to next time you need to fine tune or if you need to update some data validation steps. Second one, missing data. So let's say that you're collecting a bunch of data points for the students. Maybe it's their student ID, their phrase. You might also want the native audio, which is the correct pronunciation for a word, and then the student audio, which is the student's version of how they're pronouncing a word at a particular time and a difficulty level. But maybe you're noticing some of the audios are missing some of that data. Maybe the difficulty is missing for one or the audio is missing for the other. Here's some ways you can handle for that. So for your missing audio, you just have to ask to re-record. If you're missing in difficulty levels, you can use the average difficulty from other students. So if, let's say, 95% of students are finding a particular phrase very difficult, it's safe to assume that that person probably thought the same thing too. And then the last one, you want to filter out the recording if certain values are missing. For instance, like maybe a student ID. You might want to filter that out, especially if you are if it's an app where it is individual based. So if I log on, I only want to see my information. So if I have an audio, my student ID is not there, you can't safely assume that it belongs to me. So it's probably best to filter that out. The third one is noise, and which is funny because it also fits in with this. So let's say you have some background noise in the audio. You know, you may hear someone talking. Maybe there's a train going by, something like that.
Or there's a snowblower. For those who haven't noticed, I keep muting my mic because the other Andrew keeps going by my office with the snowblower. Sorry.
Sabotage. No, I'm just kidding. But yeah, so there's some noise reduction filters and audio pre-processing that can handle that. By the way, I'm no audio engineer, so I don't know any audio pre-processing steps. Do not ask me. But there's also some audio normalization as well too. And you can also do some silence trimming. Like for instance, if somebody just long presses a button and they take forever to speak, you might want to cut off the before and afters of that just so you can only hear the phrase itself. Next is, and last one is your outliers. So let's say that there are some pronunciation scores and they're typically between 60 and 85%, but you get a couple that one is really high and really low, 2% and 99.9%. So you can either flag those suspicious ones for review, and you can have someone manually go in and listen themselves and determine on if the scores make sense, or you can automatically just calibrate those scores to be within that certain range. Like the 2%, they somehow magically get bumped up to 60%, and then the 99 gets bumped down to 85, which would really suck if they actually did do really good. But if it's an outlier compared to the rest of their audio recording scores over time, probably safe to assume that you should bump it down. Next one is data pre-processing. So let's talk about categorical data. In our pronunciation app, we have different levels of Japanese phrases that's based off of the Japanese language proficiency test. I think there's like 5 different levels, with N5 being your very basic, where you know how to say hi, hello, very simple phrases, and then advanced, which is N1, and that is your basically fluent. But AI models don't understand those categories like beginner and advanced. So we have to convert those into numbers, and you do that with encoding. There are a couple of different coding techniques, and it just depends on what you're, what you're solving for, what your data is like to determine that. Of course, you know, you have one hot encoding, which is what I have on the right, which is where, since it's a phrase, you might use multiple words, so it's breaking it down that way. You might also have just a basic encoding, where you just literally assign a category, a specific value. Next one is your standardizing your speaking needs. So standardization help us to understand how unusual a value is or how usual it is, depending on your entire data set overall. So when we're standardizing speaking speeds, we're just not looking at the raw numbers. We're seeing how each student compares to the average speaking student. So a score of negative zero point 0.5 means that they're probably slightly slower than average, while 2 might mean that they speak significantly faster. So this is crucial for our AI to understand what normal speech patterns are and identify areas where students might need help. Like, hey, you're a little slow today compared to our students. Maybe, speed it up, or here's some drill exercises we can use to help you get up to speed or at least average. You probably won't word it like that, by the way, but yeah. And then finally, you have your normalization, and that's going to make the different scoring system compatible. So let's say that you have a bunch of experts who have their own scoring system for how to manually score students, and they have some like forfeit. You have 85%. Then you have some that are 10 out of 25. Those are very different ways to grade, and it's kind of very confusing. So you want to standardize that format to where it makes sense. And in this particular example, it probably makes sense to convert them all to percentages to begin with, since the scores are between like 0 to 1 anyways for a normalization scale. Because you do want to compare that performance across those different exercises and scoring systems. So for our app, this lets us create consistent tracking or progress tracking regardless of the exercise type. So the key takeaways for students, by the way, in coding, you're making categories computer friendly, converting it to numbers. Standardization, it shows you how unusual or usual a value is compared to the rest of your data set. And then normalization, you're making all the different scales or way that you rate your data comparable and easier to digest. Next is data set splitting. So we want to make sure our AI pronunciation coach can help with any student, not just the ones to practice with. So you want to think of it like training an actual human language tutor. So first we'll have our training set. So we'll use 70% of our data for that training. And this is really where the AI learns what's good and what bad pronunciation sounds like. So let's say you're taking like 700 pronunciation recordings, and it's going to include some easy phrases, some common phrases, some various student accents, so it understands how to interpret the different ways someone pronounces something. And then also you want different proficiency levels as well too, just so it has a wide range to take in and understand. The validation set, we'll make that about 15% of our overall data set. That's similar to having the tutor practice with a few students to understand and to understand, as well as while we observe and make adjustments. So maybe we'll notice that they're too strict or they're too lenient with certain sounds. So we'll fine tune their approach and say, hey, you should speak up on this, or, this pronunciation is fine. It's a regional dialect. Let's dial it back a bit. They're okay. And and then you'll use that to check if you can handle new student voices, adjust pronunciation sensitivity, and again, we'll fine tune our feedback. The last one is our test set, and that is where we're going to use the last 15% of the recordings, and it'll be completely separate from our test set, by the way. This is like the tutor's final evaluation with completely new students, just to see how well it learned and how it can interpret pronunciations. So if they do well here, we'll be confident that they can perform and take on any new student or any future student. So the pros of this is it's never supposed to be seen by the AI before until now. It'll prove that it can handle the real world scenarios, and it also makes sure that the AI is spitting out patterns is picked up versus memorized data that is taken in. Because a common mistake that's seen with testing AI, especially with data it's seen before, is that it's kind of similar to like taking a test and then the teacher gives you the test again and expects a completely different situation or you not to perform better. It's easy to memorize those initial questions and answers and then do better on the second test because you already have that memorization there. Versus if you have a randomized second test, it'll be you having to take in a fresh perspective of the answers and questions that you've seen. So maintaining all that strict separation of all those data sets, you'll ensure that the AI can genuinely help your student improve over time and also understand and adapt with diverse students and as well as speaking types.
Just to talk to the split here, and this is specific about LLMs, but LLMs are a bit tricky because they're given so much data
Mhm.
that some folks don't even realize that their test data is already included because it might be on the internet. So, for instance, let's say we are training this to take the Japanese proficiency test, and um, you give it questions, but you don't realize that it's scraped like in that data set, like in your it's not labeled data, but it's just raw data that was used in the large language model might have like hundreds and hundreds of pre-tests, and you don't know. And so that's where that stuff can be skewed. So there has to be a way to really know that that test data is. But that's a challenge with LLMs in particular for very specific use cases, which I found was really interesting. I think this obviously applies to all AI workloads, or sorry, ML workloads or machine learning workloads for validation. But I just wanted I think that was a edge case I heard about.
Yes, and that's also why I think annotation and labeling of data, as well as being transparent about those training sets, helps, especially for companies that are trying to go in and add in their own, RAG systems and things of that nature to help. You don't know what the model's already been trained on, so for all you know, you could send it conflicting information, or as you said, stuff that it's already seen before. Yes. Next one is feature engineering. So that is like teaching our AI what to pay attention to. And then, by the way, again, you want to think of it as helping the AI notice what humans naturally observe. So imagine you're helping someone to learn Japanese. You naturally notice things like pitch, speed, and rhythm. But our AI, it doesn't know those. So you actually have to help it identify those aspects and measure it. So let's break it down with an example. So when our student records their Japanese phrases, we don't just feed the raw data to the AI. Instead, we want to create some meaningful features. As we talked about, that's just data points that are relevant to your use case. So we'll extract the pitch pattern and see if they're hitting the right highs and lows. We'll measure speaking speed to ensure it's natural. We'll even analyze pause patterns to check if they're breaking words correctly. But we go further than that. We definitely can make it more advanced. We can combine those basic features and create more sophisticated insights. We can track improvement over time, identify consistent error patterns, and even understand how factors like practice time and word complexity affect performance. And if you think about it, this is kind of what Duolingo does to help you get a better perspective of how our pronunciation coach will work. So one of our most powerful engineered features is what we call the mastery indicator. That's what's going to be for our app. It'll combine consistency, accuracy, and speed to give a single score that really tells us if a student has mastered a particular sound and phrase and if they're ready to move on to the next proficiency level. Next one is the data labeling and annotation. And then again, why do we label data? We just want to help make sense of what the AI is hearing. And it's also good for us in the case that we need to go back and do some validation checks or updates to any of the data that we've had before to fine tune the model. So let's talk about this in the context of our AI and how to judge pronunciation. So you want to think of data labeling like having expert Japanese teachers listen to thousands of recordings and then mark them back with detailed feedback. When we get a recording of, how are you, whatever that is in Japanese, we don't just mark it as good or bad. We'll have to create detailed labels that capture everything an experienced teacher would notice. So is the pitch pattern perfect? Is it nice? Is it correct? Or the vowels the right length? Is the rhythm natural? One of the most important things we label is error types. For example, many English speakers struggle with the pitch accent in Japanese, rightfully so. But labeling these specific mistakes, our AI learns to identify and provide targeted feedback on them. We can also add some context, so a slight pronunciation error from a beginner might be acceptable, but the same error from an advanced student, it needs correction. So these context labels helps our AI provide appropriate level specific feedback. Let's talk about how we ensure quality and apply data labeling in the real world. Again, it's my favorite word for now, but it's crucial because your AI can only be as good as the training data, as we've mentioned a million times before. So for quality control, we implement what we call the multiple eyes principle. So think of it again as having several teachers grading the same test. You have multiple expert reviewers, they label the same data looking for an agreement. And then when they do disagree on some of the data or some of the speaking, that's really good information because it helps us to identify areas where even the experts might have issues interpreting the assessment of the speaking. So let's say we have an audio recording of a student practicing Japanese. Our label process will work something like this. So for the first pass, an initial expert might label it as, hey, you need some, it has correct pronunciation, but there's a couple of error types that are there. And it also notes some unusual patterns. Another one will do a second pass and they'll either confirm or challenge the first assessment of the first grader. They'll add any additional observations and flag any disagreements. And then the final verification step is a native speaker does a final check. It ensures or validates accuracy of those labels or the grading that was assigned to it. It ensures natural language patterns are captured and it provides cultural context if needed, which is actually a very, very good edge case because this multi-layer approach, it helps us to catch things we might otherwise miss. For instance, what one reviewer might flag as a pronunciation error might other will actually be a regional dialect variation, and only and another grader might pick that up, but that's only because they're familiar with that. So that's a good way to eliminate bias. We'll also regularly update those labels as the language patterns evolve over time. And then remember, because language is living and dynamic, what's considered correct 5 years ago might have subtle differences today. The real impact of this quality control becomes clear when you see how the AI responds to new students. Instead of just saying incorrect pronunciation, it can provide specific, actionable feedback like your pitch rises too sharply on the second syllable, or try shortening the vowel sound slightly. And that's our advanced version of our pronunciation app. Next one is data privacy. And privacy isn't just about compliance, by the way. It's about trust, which is extremely important, not only amongst your coworkers and yourself, but also with your users. So when the students use our pronunciation AI, they're sharing their voice, they're sharing their struggles, and they're sharing their progress. And that requires them to be extremely vulnerable with us. So we have to handle the data with the utmost care. So let's look at how we protect the student data at every single level. First, we anonymize everything. So maybe we don't use their names and their personal details like their address or anything like that. We'll just create unique identifiers and mask and scrub anything that's irrelevant, which is also important because we have to make sure that all the correct data is in the right hands at all times. So also, if someone even accessed the training data, they couldn't identify individual students, even the people that work on the data day in and day out, because it's not relevant to them. So voice data is particularly sensitive because it's biometric information, by the way. So you encrypt all the recordings. We can separate identifying information from the actual training data itself. And then when our AI learns from these recordings, it uses completely anonymized versions. Think of it like having a privacy shield around each student's learning journey. They'll track their own progress, but nobody can connect specific recordings or performance data to them. And then for the compliance part, you do want to have a compliance checklist, depending on what region you're in, what international contracts you might have. You might have some type of, like GDPR compliance. You might have data minimization that you have to do as well too. Consent management is also very important with making sure that people are able to opt out for certain types of data that you might collect. They also might want to have the right to be forgotten completely. And then lastly, your data retention policies. How long can you keep data stored in a certain place? Do you have to send it off to some type of cold storage where it's never going to be accessed again after a certain amount of time? And then is there a deadline for deleting this data after a while? Very important to keep a track of. And then we made it to the end. Here's our key takeaways. So first, quality first. You want to do good pre-processing because that means better AI. Consistency matters as well too. Like we said, you want to standardize your process, make sure everything's formatted, and make sure that there are no anomalies. Third one, privacy always. You want to protect user data from day one, not just from outside world for hackers, but also from internally, making sure everybody only has hands on the data that absolutely needs it and it's the right data. Last one, which is the biggest thing, no matter what industry you're in or what your role is, document everything. Future you will thank you, especially when it comes to annotating any data, any labels, even if it's where you're pulling data from, popular queries or things that you use, your data quality checks, your validation checks. You want all of this to be stored because in the end, when you need to troubleshoot or there's any type of compliance issue and you have to go back and show evidence, you'll have all your ducks in a row and you'll be able to easily present that. Also, even if you're trying to onboard new team members or you're having to teach someone else something that you have done, that's also important as well to make sure there are no bottlenecks or there any dead ends to where someone doesn't know what happened with this model because somebody left and then they took all the knowledge with them. So incorporating these incorporating these pre-processing techniques and best practices into your workflow will help you to build more reliable and performative Gen AI models. So you do want to pave the way for innovative applications because I think that again, pre-processing it's more of an afterthought at this point, especially across depending on what domain you're in. But remember, the success of your AI projects often begins with how well you prepare your data. So invest the time and effort into pre-processing, and you'll reap the rewards and performance of your models. It'll also help you to stand out in your job and also your job search as well. But that's the end of my presentation. Thank you all for following along with me.
And clearly, there's a lot of things that have to be done to ensure your data is in good shape. I'm definitely not doing all those things, but you know, one day you'll learn your lesson and you'll know why that there all these steps do exist. But and obviously, yeah, the pipeline is going to look different depending on what model you're using and what data structure you have. But now we have a grounded example that we can utilize in the boot camp. Yeah, I just appreciate your time coming out here and giving us a clear understanding of what that pipeline looks like. And we'll see how we can incorporate into our upcoming weeks here. And again, just want to thank you for coming out here. And we will see all of our boot campers here soon. And we'll just say ciao, ciao.
All right, bye.
Or
Happy
merci.
learning.
Or it's not merci, but bonsoir. It's not nighttime.
Bonsoir.
That's all I can remember right now. So
You know how to
yeah.
say bye in Japanese?
I should. Yeah, I mean, we could say sayonara, but you would say ja matane. So ja matane is what we would say.
John Martinet. Adios.